In question 7, we have 3 points that have coordinates a 0, 7, b 8, 3, and c 3k, k. We have to find the value of k for which c lies on the line that passes through a and b. Now, as c lies on the line that passes through a and b, we can attempt this question in two different ways. We can use the gradient formula as if points are on the same line, the gradients are equal. So we can equate the gradient of AC and the gradient of CB. As the C coordinates have the same variables, we'll be able to find the value of K. Or we can find the equation for AB and substitute the values for C, which are 3K and K. So if we find the gradient for AB, we'll get y2 minus y1, which is 3 minus 7 divided by 8 minus 0. So the gradient will be minus 4 upon 8, which is equals to negative 1 upon 2. So the equation for AB will be, we can use the point A for the equation. So the equation will be y minus y1, which is 7, is equals to negative 1 upon 2 into x minus 0. Simplifying this, we'll get 2y minus 14 is equals to negative x, or we can write it as 2y is equals to negative x plus 14. Now to find the value of k, we can substitute 3k in place of x and k in place of y. So we'll get 2 into k is equals to minus 3k plus 14. Simplifying this, we'll get 5k. So this will become 2k plus 3k, which is 5k equals to 14. And k will be is equals to 14 upon 5. Or we can write it in decimal as 2.8. In part 2, it says that find the value of k if C lies on the perpendicular bisector of AB. Now, if C lies on the perpendicular bisector of AB, it means that the perpendicular bisector, which is a right angle. So first we'll find the equation for the perpendicular bisector and substitute the values of C, 3k, k into that equation. Now to find the equation of the perpendicular bisector, first we'll find the gradient of AB, which we already have as negative 1 upon 2, which means that the perpendicular bisector will have a gradient of positive 2. Now to form the equation, we need the midpoint as the perpendicular bisector passes through the midpoint. So the midpoint of AB will you find using the formula x1 plus x2 upon 2. So that will become 0 plus 8 upon 2, comma 7 plus 3 upon 2. So 8 upon 2 will be 4 and 10 upon 2 will become 5. So this is a point on the perpendicular bisector. To form the equation, we'll again use the formula y minus y1. So y minus y1 we can take as 5 is equals to 2 into x minus x1, which is 4. Simplifying this, we'll get y minus 5 equals to 2x minus 8, or y is equals to 2x minus 8 plus 5, which is equals to 2x minus 3. Now substituting the values of c 3k, k into this equation. So in place of y, we'll put k, and in place of x, we'll put 3k minus 3. So this will become k is equals to 6k minus 3. Simplifying this, we'll get k minus 6k is equals to negative 3. Minus 5k is equals to minus 3. The negatives will cancel out. So k will be 3 upon 5, or we can give it in decimal as 0.6.